Okay, guys, we've been getting quite a few questions about the problem solving parts of the third fractions exercise. So, when the questions include a lot of context, so plenty of words and things like that. So, I thought I'd do a little reminder and maybe go through the first set of questions. Um, so, the first thing to do or to remind yourself of here is some of the language that can lean or allow you to lean towards a particular mathematical function. These are not set in stone, it's not something that you'll always see, but in first year, you'll have probably done some work, first and second year, on mathematical language. So, a couple of common phrases that usually have a connection to the function. So total, sum, together, they tend to suggest an addition, difference, and asking if something can be left over. What's left over tends to lend itself to a subtraction. Altogether, that can be where there's multiple numbers of the same object. So let's say we want to buy 4 donuts. So what's and each donut costs 50 pence. What is the total cost or the cost altogether for multiplication? That does kind of mix with the total and the addition section because you can do 50 plus 50 plus 50 plus 50, or you could do your 4 times 50. Now, another one that's a little bit more um, uh, complex, it's more related to your national fire, and as you move further forward, is the word of. And I'm going to kind of give you an example of where of means multiplication. So on your BODMAS, okay, you might find that you have fractions of, so 2/3 of 18, okay. Well, that's another way of writing 2/3 times 18. And we don't normally do that when it comes to fractions. You could also have 36% of 100 grams. That's the same as saying 36% times 100 grams. And in that instance, we would be changing the 36 into its decimal form of 0.36. Now, those are little shortcuts that we can use, and that's probably the most important thing to remember when dealing with these kind of wordy fraction questions. That fraction of will tend to mean multiplication. Okay, so there's also for division, if you're looking to share something or spread evenly or split, that can be something that connects very closely to division. Those are the words you want to be looking for. So I will kind of show you as we go through this these 3 examples. I think that there's 3, sorry, in the multiplication, and there's 1 or 2 more in the division. One additional phrase that you'll have used most definitely when you were in primary school, I think when you were first introduced to fractions, you would have been given the phrase 1 out of 2. That's likely to be the first fraction that you saw, and you know that that's 1 over 2. And then as you progressed, you would have looked and maybe had shapes that were split, and you would have been asked to name the fraction that's shaded, and you would have described that 3 out of 4, okay, were shaded, which, if you follow the same method, is the same as 3 over 4. And that phrase out of, okay, is something that you are most definitely going to see when you deal with these types of questions. So it may be that within a question you have to transfer out of into a fraction. Okay, I'm not going to go through every question, but just as an example of the language and the connection to the mathematical function, like I mentioned before, we look at question 8. We've got Brian drank 4 1/5 litres of water and 2 3/4 of milk yesterday. How much fluid did he drink altogether? And if we look back at our table from before, how much did he drink altogether? That's altogether suggests that we're going to be taking a total, so it's an addition. Question B, how much less milk was there than water? That is not saying the word difference, but if you're looking to find how much less there was of milk than water, then that would suggest a difference. So rather than going through the full example, because we've done a fair bit on addition and subtraction, I'm just going to show you what the questions actually mean. So in question A, we're literally looking for 4 1/5 plus 2 3/4. And in question B, this time, how much less milk than water? So 4 1/5. We're finding the difference between that and 2 3/4. So it's the language we're looking for. This altogether is what suggests the add, and how much less is kind of going to suggest a difference. Okay, not quite as clear as the word difference, or what's the difference between the volume of milk and the volume of water, but still it kind of suggests it there. Okay, moving on to question 8. If we have Fabio's restaurant, 40 out of 70 dishes on the menu are vegetarian. So it's important there in the first instance that if we're going to look at dealing with these fractions, we need to change that sentence. It's 40 out of 70. And when you were probably in primary school, you used that 1 out of 4 for a quarter. So 40 out of 70 is something that we would look at. So out of means over. Of the vegetarian dishes, 5/8 are pasta dishes. So what fraction of the dishes on the menu are vegetarian pasta? So what we're actually looking at there is we're looking at 5/8 of the number of vegetarian dishes. And the number of vegetarian dishes was 40 over 70. So the sum that you would be looking to do is just 5/8 of 40 over 70. And I mentioned before that the word of changes to times. I won't go through the fraction, but you can simplify diagonally and then get your final answer as you would have done before. So the key things here, again, would be changing the 40 and the 70 into a fraction, and then recognizing that there's a combination of the vegetarian and the pasta dishes, okay? And then finally, the word of changing to a times. Right, question 11. On Monday, a team of window cleaners cleaned 5/8 of the windows on a high-rise. On Tuesday, it was raining, and they only managed to clean 2/5 as many windows as Monday. So this is tricky in the sense that they try to connect these two fractions. So what fraction of the building's windows were cleaned on Tuesday? So on Tuesday, they cleaned 2/5 of the windows that they cleaned on Monday. Now, the windows that they cleaned on Monday was 5/8 of the windows. So if they only managed 2/5 of what they achieved on Monday, then that's 2/5 of 5/8. And we now know that of changes to a times, so we get 5/8. So 2/5 times 5/8, something that we can go through quite quickly. The diagonals will cancel to give you 1 and 1. We therefore have 2 over 8, which simplifies to a quarter. Okay, now the only reason I'm going to follow that through is because they connect question 11a with question 11b. So at that stage, we have a quarter of the building's windows being cleaned on Tuesday. What fraction of the building's windows remained dirty? Okay, so that means we have altogether 5/8 on Monday, and on Tuesday 1/4. So what is that altogether? Altogether 5/8 plus 1/4, and naturally you can see we don't have common denominators. We change the quarter into eighths. This is a nice easy one. So 2/8, and you'll recognize that actually if I hadn't changed it earlier, I might have been able to do that a little more seamlessly. So we have 7/8 cleaned. But that's not the question. The question is how many remained dirty. If you have a look up here, I'll do it in green. Okay, so how many remain dirty? Well, clearly if we have 7/8, the dirty windows is 1/8. Okay, the entire set would be one whole number. 7/8 is 1/8 short of a whole number. Right, on to the division type questions. There's only 3 here, so I can maybe get through these all in a one-hour. I'm not going to follow them right the way through, but I'll be able to give you hints towards the right kind of calculation. So how many 2/5 are there in 3/10? Question 3. If I was to say to you, how many 5s are there in 20? Then hopefully you would recognize that would be 20 divided by 5. So in this case, for question 3, how many 2/5 are there in 3/10? So that's 3/10 divided by 2/5. Okay, not one that has a anything overly complex in the sense of the language, but it's obvious that at times when you're given this in a context where there's fractions, all the stuff you've learned previously does find it's harder for you to access it. So if I had said to you, how many 5s are in 20, you would automatically do 20 divided by 5. This is the same, except it's fractions. So question 4, how many pieces of cloth, 1/8 meter long, can I cut from a piece 2/3 meters long? So how many pieces of string, half a meter long or 50 centimeters long could I get from a meter long? If you were to wrap your head around that, you would probably just add them up till you get to the total, or you could divide. So this is another one where it's the divide. So 2/3 divided into 1/8 and process from there. Question 7. Okay, 2 and 1/4 laps of the park took Tommy Muir walking his dog 12.5 minutes. How long on average did one lap take? So 2 1/4 laps took Tommy 12.5 minutes. So we're looking to see what it would take to do one lap. So 2 1/4 equals 12.5 minutes. So if we're looking to change one, what we would have done here is we would divide this by 2 1/4, and therefore we must do the same, 2 1/4. So the sum we're actually going to be looking for in question 7 is 12.5 divided by 2 1/4. Okay, now if we were to make that a little bit simpler with different words, if I had said to you it took me 42 minutes to complete 6 laps, how long did it take me to, on average, to complete one lap? Then hopefully you would recognize that you need to do the 42 divided by the 6. Okay, now the theory behind doing that is exactly the same. It's just its fractions. This thing here that we're looking at is something you might have seen when you were dealing with fractions. Sorry, not fractions, percentages, but it's another way of looking at that division. Ultimately, we need to recognize that you're trying to split that time into 2 1/4 laps. So we're splitting, so it's a divide.